Welcome back. This is your last section or chapter of the construction math course that we're offering here for just kind of review and preparation for either the superintendent's exam or just for general work in the field. For this section, we're going to look at how to calculate volume for various objects. Okay. So with area, we were looking at two-dimensional space. Like I said, something flat, an area rug. Looking at just, if we were just set it down on the ground, how much space does it take in that, just lying on the ground, okay? Flat. Volume, we're talking about three-dimensional space. So we've got that area. We still have that space that it's covering on the ground, but now we've got height. It's going up as well. It has volume. So it's going to be very similar. It's just another step. We're just adding on another step to calculating the area, basically. We're starting with the area, but now we're going to multiply it by its depth or height or whatever else we have going on in there, that third dimension. So we're basically just taking another step. That area we computed already for that shape, when it was just, we're looking at just the end of that shape, and adding that third dimension to measure that along there as well. Okay, and our units, again, as we reviewed kind of earlier, we're talking about volume, we're talking about cubic inches, cubic yards, cubic feet, however, whatever units you're using. So here's an example. This is the volume of a rectangular solid. Now remember, the area was just this flat edge right here, just the length, and we can call it height or width, whatever. It's these two edges. We multiply those two, it tells us the area of just this side of this box. But if we want to know the volume that this box would hold, the volume of that box, we also have to multiply it by this depth or width, whatever this third dimension is. So that's all we're doing. Okay? So for example, for this box, it is 4 feet tall, 12 feet long, looks like 5 feet deep. All we have to do is multiply those three measurements together, and we get 240 cubic feet is the volume of this box. So basically taking, recalling what you learned from area in terms of and then just adding that other dimension on, or multiplying by another dimension. Turn to worksheet number 8 and complete exercises 1 and 2. And when you have finished, resume the video for the answers. Okay, here are the answers for worksheet number 8, exercises 1 and 2. And I bet those are the answers that you arrived at. If not, then circle those and let me know. We'll see what we can do to maybe work through some more of those. So continuing on, this is a rectangular trapezoidal kind of solid, okay? So you may have something that is shaped like this, that at the end of it, it looks like that trapezoid we talked about earlier. Also looks like a rectangle and two triangles, right? So we need to calculate what this flat side is, and then we need to add, multiply it by this last dimension here as well, the depth of it. That's going to tell us the volume of that shape, whatever it is. So we know it is, for the trapezoid, the formula for the area is 1/2 the base plus the base 1 plus base 2, right? So we've got base 1, 20, plus base 2, 30. We're adding those. Taking 1/2 of it, or dividing by 2, that's going to give us the area, 200 square feet. But to get the volume, we also have to multiply that times this 40 feet along here, this depth. When we do that, we get 8,000 cubic feet. So area was 200 square feet, this flat edge, flat facing piece here. The depth of the whole thing, the volume of the whole thing is 8,000 cubic feet. If you have a triangular solid, same concept. You're looking at, remember what the area of a triangle is, what the facing edge of this is. This is a triangle. The area of a triangle is 1/2 the base times height. Here's our base, here's our height. And then you're going to multiply times the length to get the volume. So here's an example for that. We have a base here of 5. Looks like we have a height of 3. So 1/2 the base times height gives us the area of this little triangle here. We're multiplying it by the depth of this object, the 7 feet. That gives us 52.5 cubic feet is the volume of this. We would call this a prism, basically, or a solid triangle, triangular box or object. Okay, so let's pause the video and on worksheet number 8, complete exercise number 3 and see how you do with that. Okay, so for number 3, you didn't get a picture with that one, so it might have made it a little bit more difficult for you, I don't know. But what they're telling you is that you have a long baseline of 36 feet and you have a short baseline of 28 feet. Okay, so that sounds like a trapezoid, right? We've got, you know, 2 different baselines, different sizes. And then we know that the depth of this is 4 feet. Basically what we're saying is that is the height, right? So we're going to calculate first the area of that shape. It has we've got base 1, base 2, and what they're calling the depth is actually the height. So 36 feet plus 28, divide that by 2, excuse me, and then multiply it by 4. So the area of the shape, that facing piece of it, is 128 square feet. Once we add the length of this object, it's 2,640 feet. So we're going to multiply this by 2,640 feet to determine the volume of this object. And this is the answer we should get. But they ask for the answer in cubic yards. We have cubic feet here. So we're going to divide again. To convert from cubic feet to cubic yards, we divide by 27. And that should be our answer. So that one's a little bit challenging because you didn't get a picture. You had to kind of sort that out based on the narrative that you were given. Volume of a cylinder. Again, what we're talking about is, remember what the area of a circle is, right? Pi r squared. That is going to be the area. We're multiplying that by the height. For example here, we've got a radius of 5 for this circle at the top, for this drum. Basically looks like a drum to me. And we say it's 13 whatever feet, inches, whatever the units are. It's 13 feet tall. So we plug that into, first to calculate the area of this, it's pi r squared. So we've got pi, r here is 5 squared, and then multiply that times 13. We calculate that out, we get 1,020.5 cubic feet. Okay? Alright, pause the video now and complete exercises 4 and 5 on worksheet 8 to work out a couple more volume problems. When you are finished with that, resume the video. Okay, so for problems number 4 and 5, we've got pi in there for each one of those, 3.14. We've got the radius of 4.9 feet for, and that should just be feet, not square feet there, for the radius of that circle for the cylinder. And we have a height of 7.8. Once we calculate that out, once we square the 4.9, we get 588.05 cubic feet. And then for the next one, we have, it's a 12-inch radius, and it is 34 inches tall. So hopefully those are the answers you arrived at. If you have, ta-da, you're done. You're finished with the construction math course. This is as far as we're going with this course. We hope to develop additional courses as we move along that get more in depth with math that you would use out on the job in terms of construction, but also finance, to kind of fill that need as well. If you have any questions on any of the exercises or any of the concepts we've covered, please feel free to contact me via email or phone number. The information is provided on the materials that you downloaded, and we'll set up a time to go over any material that you would like to have covered again. Thank you very much for your patience and your time. As I said, this course is generally covered face-to-face. We present this face-to-face. It's a little bit difficult to do it and listen to it video and go through the materials. But we hope this was helpful to you, and good luck with your exam.